Welcome to Power Up, the Uptime podcast focused on the new, hot off the press technology that can change the world. Follow along with me, Alan Hall, and InnoSource Phil Totaro as we discuss the weird, the wild, and the game-changing ideas that will charge your energy future. All right, our first idea comes from the brain of Max Bogle-Wind AG, and it is a really unique patent. When you deal with concrete towers like you see on Nordex turbines and some Acciona turbines, where they stack the concrete cylinders on one another, have you ever asked yourself, how do those keep from tipping over and everything landing on the ground? Well, there's a series of tension cables inside of there that keeps those things stacked up properly and provides pressure the whole time. That is a really tricky system. And this patent idea, which is a pretension element, creates this mechanism to provide tension and simply on these concrete towers so they don't fall over and don't come apart like kids' blocks. And Phil, this one I think is being used, right? I would assume that this technique, because it's really unique and simple and effective, has to be out in service already.
Yeah, and we believe it's being used on some of their hybrid concrete and steel tube towers. So just for everybody's benefit too, this is kind of a pre-tensioned tower anchor concept where, the benefit of that is if you if you want to be able to control the amount of load and deflection, pre-tensioning can kind of help facilitate that versus post-tensioning something where once you've already poured concrete and it's hardened, there's only so much kind of post-tensioning you can do without overstressing either the tendons or the concrete itself, which could weaken it. So pre-tensioning this allows you to, have the correct amount of tension in the tendons and the anchor bolts. And then when you're laying in your concrete, it's going to help facilitate the strength and reliability of that connection. Now, what's also kind of fascinating about this is that we've seen, kind of pre-tensioning and post-tensioning used in different areas of the turbine before. Where some of the companies, Vestas, I think, tried a post-tensioned tower with guy cables and things like that. So there have been companies that have tried different arrangements and techniques before, but it was never really widely adopted. But Max Bogle, obviously has the pedigree in wind energy to have this more widely adopted, and the hybrid towers that they've been deploying, I believe, number more than like 300 or 400 at this point that they've got deployed, mostly throughout Europe, I believe. So, this is fantastic technology, and again, great to see that somebody's capturing IP on a technology that they're actually rolling out commercially and getting the commercial benefit out of leveraging.
I think an important note here, pre-tensioning. So just to give example, if you're not familiar with concrete pre-tensioning or post-tensioning, think of the easiest example of concrete pre-tensioning is when you make a bridge beam, and you see the bridge beams have a little bit of an arc to them, kind of. How that was made is you put cables through a form, you pour concrete in the form, and while that form is still wet, you put tension on those cables on the outsides of the form, so they actually, they'll pull on the inside. And then once the concrete sets, you release the form, and now it puts pressure on that concrete. And concrete is always by strength of how well it's pushed together. So PSI, the pressure of concrete, is how strong it is usually. So when that pre-tensioning is done, it makes the connection stronger, it makes the piece stronger, it makes everything stronger. So that's the technology they're using here. So switching gears to going, how is this used in the field, or what does it look like? In the United States, we don't have a whole lot of concrete towers. And in general, concrete towers aren't that widely used. To my knowledge, I'm not a developer. I haven't looked into the commercial models or the business case for concrete versus steel, but I know steel's pretty dang easy to just roll to site and boom, 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 put up. So I think that's why we see more steel ones than concrete. But technology like this may change that in the future.
Our next idea is from Vestas, and they have a patent and really a really strong idea about the control system in their turbines when the turbine isn't pointed in the right direction. So they can get yaw off center from where it needed to be. It's not really pointed in the wind, and that can cause the tower to sway. And once the tower starts to sway, that can set off an alarm and shut everything down, which you don't necessarily want to do. So this patent idea looks at where the yaw error is and derates that switch, the vibration switch on the sway, to say, hey, we're just out of yaw. Let's get back in the right direction, and that swaying that is happening will go away. So it's like a temporary way of reducing this control system so that the turbine continues to operate and produce maximum power. It's a really complicated thing, though, because as turbines have gotten more instrumentation and more control systems, there's a lot more alarms in a turbine than there ever used to be. And tower sway is one of those. This tries to deal with some of the unique situations that pop up with yaw.
Yeah, and what's kind of interesting about this is you're right, because we now have, algorithms in the turbine controller that you would think would overlap or compete with each other. You've got yaw angle optimization for controlling wake. You've got pitch angle optimization for performance or noise. And so there's all kinds of things that you might be doing at the same time. And I think this is a solution that they came up with specific to a problem they might have had with, a specific tower frequency or something like that, where, you were getting this oscillation and you want to be able to leverage the yaw error as an input to this algorithm that's basically going to determine, how do you reduce the amount of wobble. We were talking off air about this is almost like, if you've got like high speed wobble on a, well, I get it on my scooter, my electric scooter. Sometimes you got to lean forward or throttle back a little bit to be able to, just get out of that oscillation window. And then you can get back to normal operation.
Yeah, I think that these problems didn't exist a long time ago, right? If you think about this is a Vestas patent, right? Yes. So if you think about a V47, it's stout blades, not a whole lot of flexibility, not a whole lot of movement, not a big tall tower, not 70-meter long blades. So it could handle vibration a bit better. Whether that's vortex-induced vibration, of the tower with wind going past it, or it's vibration induced by the rotating equipment within the tower. Now, we're getting bigger and bigger and bigger. This patent's from 2021, so that was right when Vestas was coming out with like the V150. Now we're in the V163. So these things are getting bigger, taller, longer blades. So they're a lot more sensitive to motion-induced or rotational imbalances induced issues within the turbine. So they're coming up with controller methodologies to fix some of these problems. I think that's something we definitely have to be doing as it's going to get as we get larger and larger. And I think you'll see more and more OEMs having to chase this same dragon.
For our fun patent of the week, we go to Hollywood. And some of the most famous patents that we actually use today have come from Hollywood. The Marx Brothers were involved in a number of patents and products that are used in aerospace today. Hedy Lamarr, the famous actress, has a patent for frequency hopping, which is a way that we transmit signals and code today around the world. Well, this one is a little more common usage in that it's a special pair of shoes that you have seen these shoes if you'd watched MTV before in Michael Jackson in that video Smooth Criminal. And when you see Michael Jackson sort of lean forward, you're like, oh man, that's amazing. How did he do that without falling over? Well, he had invented a special shoe. And in this shoe is a little slot in the heel. There's a slot, and it picks up a bolt head that's built into the floor. So you kind of lock yourself into the floor, and you can lean forward. And Michael Jackson is one of the inventors of this system, Phil. It's quite interesting that they went ahead and patented it to keep others from copying it.
Yeah, well, besides that, it's actually something that they ended up using for the live stage performances back in the 80s and 90s. And, it's funny because when they originally shot the music video, the lean, the famous Smooth Criminal lean was kind of done with just Hollywood tricks. and I forget what the specific system was, but they wanted to be able to do this maneuver with all the dancers, including Michael, at a live stage show. So they had to come up with a system for how to handle this. I don't know if even at the time, I don't remember this back in the 80s, but I don't know if everybody even knew how it was being done at the time. I think it was everybody just assumed it was like magic, or he was actually like leaning over and, was just in control of himself that much. Like, it's fascinating to see how like IP can end up kind of popping up in random places, like, the entertainment industry, or how we use technology in wind. I mean, it's a similar kind of thing where the dumbest, cleverest little things can end up being the most revolutionary.